All right, guys, so this is the start of chapter 7. So this is section 1 of chapter 7. And chapter 7, we're going to talk a lot about just various polygons. This first section, we're going to kind of be all around like every single polygon out there we're going to learn about. But after this section, we're going to zone in more on special types of polygons like parallelograms and quadrilaterals. Quadrilaterals aren't really that special. Special quadrilaterals like rectangles and rhombuses and squares and trapezoids and kites and things like that, and the properties that go along with them. All right, so as we start this, we need a few vocabulary words. So a diagonal is a segment that joins two non-consecutive vertices of a polygon. Okay, so most of you know that if we have this rectangle here, this would be a diagonal, or this would be a diagonal, and that's correct. But I want you to recognize that if we have this here, whatever this is, 1, 2, 3, 4, 5, 6. So this is a hexagon, 6 sides. That anytime we join two non-consecutive vertices, so vertices are the points, okay, all the way around. So like this would be a diagonal because we're joining two non-consecutive vertices. But this is also a diagonal, and this is also a diagonal. So you can have more than one diagonal from the same vertex, okay? You can't in a quadrilateral, but as you get bigger, you can draw more and more diagonals from the vertices. All right, so an equilateral polygon, guys, here's the key word here, equilateral. And as you could probably guess, an equilateral polygon is where all sides of the polygon are congruent. Okay, so every side is the same length. Now, equiangular polygon, keyword equiangular, and like I said, you can probably get this one too, is a polygon in which all angles are congruent. Okay, regular polygon, guys, this is kind of a big term. This helps us quite a bit. And you're going to see it quite a bit too, so make sure you know it. It's just a polygon where all sides and all angles are equal. Okay, so all sides are congruent and all angles are congruent. Now, I know last chapter we talked a lot about in a triangle, like if all three sides are congruent, then all three angles are congruent. If two sides are congruent, then two angles are congruent. That is only true for triangles. Okay, that is not true for other polygons. You can have a 10-sided polygon and have all the same measure of sides, but all different angle measures. Okay, that's only true for triangles. So just know that unless you're told it is regular, meaning all sides and angles are congruent, you cannot assume that. All right, guys, so here's some vocab, some more vocab, and you should already know all of these. But if you don't, please take some time to learn them, because there will be some on your test that'll just be like, hey, you have a nonagon here, you know, and ask you a question about a nonagon. And if you don't know that a nonagon is a 9-sided polygon, it's going to be impossible for you to answer that question. So just make sure you know each of these terms on this page. All right, so this section, we're going to talk about the interior angles of polygons, okay? Or this video you are. And then in the next video in this section, we're going to talk about exterior angles of polygons. Okay, so interior angles of polygons, we have this formula. It's n-2 times 180. And this gives you the sum of the interior angles. Ooh, don't know what happened there. Sum of interior angles of any polygon. Okay, you will need to know this formula right here. Okay, n-2 times 180. Now this n, this is the number of sides the polygon has. So if you have a triangle, your n then would be 3. If you have a pentagon, your n would be 5. Okay, so on and so forth. So that's what you would plug in for this n. Okay, this makes sense because let's 1, 2, So here's 1, 2, 3, 4, 5, 6. Okay, so this is a hexagon. Okay, so to find the measure of the interior angles of a hexagon, so when I say the sum of all the angles, it means this angle, plus this angle, plus this angle, plus this one, plus this one, plus this one. In order to find that, we would use n minus 2 times 180. Okay, well our n here, we have 6 sides, so it'd be 6 minus 2 times 180, or just 4 times 180. And if I put 4 times 180 in my calculator, I get 720 degrees. Okay, so if I add up all these angles here, it would equal 720 degrees. And that's for every single hexagon. Now, this makes sense because if I look at this, if I draw all the diagonals I can from one vertex, okay, I'd have one triangle here, I'd have another triangle here, another triangle here, and another triangle here, okay? And each one of these triangles, if you add up their angles, it's going to be 180 degrees. Okay, so this n minus 2 is the number of triangles, or non-overlapping triangles, I should say, and the 180 is for every triangle adds to 180. I don't know, just kind of something cool. That's where that formula came from. But nevertheless, this n minus 2 times 180, know it, know it, know it. All right, let's look at an example here. It says, find the sum of the measures of the interior angles of the figure. Now, when I have this, and this is just me kind of being scatterbrained, I actually write on the sheet that I have, so I know I don't double count a side or double count an angle. I always count the vertices. You can count the vertices, you can count the sides, whichever, they're going to be the same. But when I do it, I actually write 1, 2, 3. I go around and I write the number just so I don't double count something or miss something. Okay, so I have 8. Okay, so to find the measure of an interior angle, or of all the interior angles, we'd do the n minus 2 times 180. Okay, and the n is the number of sides, or the number of vertices we have, is 8. So I could just say 8 minus 2 times 180. Well, guys, 8 minus 2 is 6, so 6 times 180. And if I put that into my calculator, 6 times 180 is 1,080 degrees. Okay, so in other words, if I add this angle, plus this angle, plus this one, 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 it will always sum to 1,080 degrees. All right, I want you to go ahead and do B on your own. All right, we just have an 11 gone here, which means it has 11 sides or 11 angles. So when we do the n minus 2 times 180, we plug 11 in for our n, and you should get 1620. All right, so let's look at example 2 now. It says the sum of the measures of the interior angle of a polygon is 900 degrees. Classify the polygon by the number of sides. So we're kind of going backwards. Now we know the sum, we just don't know how many sides we have. So we do know that n minus 2 times 180 equals the sum of the interior angles of the polygon. Okay, well, we know the sum is 900. So I can just say n minus 2 times 180 equals 900. Now, some of you want to go ahead and distribute this through, and that's not wrong. You're just making your life a lot harder. Let's just divide each side by 180 to start with. Okay, so 900 divided by 180 gives me 5. And when I do that, this 180 and this 180 cancels out, so I have n minus 2 equals 5. Guys, now to solve for n, just add 2 on both sides, n equals 7. So there's 7 sides, which means that we have a heptagon. All right, guys, there's this corollary here, and it just says, and you guys would be able to figure this out on your own if we didn't have this, the sum of the measures of the interior angles of a quadrilateral is 360 degrees. Okay, so all quadrilaterals add up to 360. So if I look at this example here, I know that if I add all these up, it's going to equal 360. So 108 plus 121 plus 59 plus x equals 360. Okay, now I've taken a geometry problem and I've turned it into an algebra problem. So this is just 288 plus x equals 360 minus 288 minus 288. 360 minus 288 gives me 72. So x is 72. All right, go ahead and use what you've learned and try to do example 4 on your own, and then we will go over it. All right, so you know that all of the angles of a quadrilateral, which we are told this is, are x, 3x, 5x, and 750, and they all have to add to 360. Okay, so we'd get this equation. We simplify it, we solve for x, we get x is 22.5. Okay, but this question didn't say solve for x. The question said find the measures of all interior angles. Okay, so when I do that, I want to plug this x, this 22.5, in for x, 3x, 5x, and 7x, which is what I've done over here. Okay, and so I get right here in black, 22.5 degrees, 67.5 degrees, 112.5 degrees, and 157.5 degrees. All right, here's the last example for this first video. There will be a second video, but it'll be a lot shorter and a lot easier. So what I want you to do is I want you to take a few minutes and try to figure out A and B on your own, and then we will go over them. All right, so let's look at this. It says a home plate for a baseball field is shown. So here's what the home plate looks like. So A says, is the polygon regular? Explain your reasoning. Well, if you don't know what a regular polygon is, you can't answer this with any success. So remember, going back to our definitions, a regular polygon has all equal side lengths and all equal angle measures. Okay, well, we don't know if the side lengths are equal or not, but we can tell that the angle measures are not. So we have 3 right angles, and then angle C and angle E are obtuse, which means they're not right angles. So that immediately tells us this can't be regular because we know the angles are not equal. So no, because not all angles are congruent. Okay. All right, so B says find the measures of angle C and angle E. Okay. Well, the first thing we need to do is we need to find the measure of all the interior angles of a pentagon, because this is a pentagon. So to do that, we would do n minus 2 times 180. Well, our n is 5. So 3 times 180 gives us 540 degrees. So if I add all of these up, it would equal 540 degrees. Okay, well, I know A, B, and D are 90. So 90 plus 90 plus 90 plus, well, E and C I don't know, but notice they have the same arc measures or arc signs, which means they have the same measures. So I'm just going to call them X and X plus X equals 540. Okay, now it's just an algebra problem, guys. So 90 plus 90 plus 90, that's 270. X plus X is 2X equals 540. 540 minus 270, so subtract 270 from both sides. I get 2x equals 270. Divide by 2. I get x is 135. So both angle C and angle E are 135 degrees.